welcome to Teach Me Maths. My name is Jonathan Hicks and today we're doing standard form. Now standard form is essentially a shorthand for writing either really large numbers or really small numbers. In many science contexts, for example in physics, if you need to measure the distance to a star, that's going to be a really big number. In biology, if you need to measure the width of a cell, it's going to be a really small number, and there are a lot of contexts where numbers can get really big or really small, and in those cases you can find you end up with a lot of zeros kicking around. Standard form was a sort of invention to make it easier to write really big or really small numbers. So before you do this, you need to understand first of all powers or indices. That's a very important topic for lots of things, but standard form relies on you understanding that. And also you should be familiar with rounding to decimal places and significant figures in particular. Significant figures really are the most useful kind of rounding, especially in science. So we'll start off with a pattern. Hopefully you'll spot the pattern and you'll realize how the system works. So if I start with a number like 2.6 and simply times that by 10, well, if you times any number by 10, you just have to move the decimal point one place, so you're going to get 26. Now if I start with the same number again, 2.6, but this time instead of timesing it by 10, I'm going to times it by 10 squared. Now if you remember from your powers, squaring means you times the number by itself. So 10 squared is 10 times 10, and that would be 100. So what we're really saying here is it's 2.6 times 100. Now if you're timesing by 100, you move the decimal point 2 places. If you go over any empty spaces, you just fill out with zeros. So in this case, that's going to be 260. Yeah, the decimal point was here between the 2 and the 6, and we moved it 2 spaces, and so I've just filled out with a 0 there because that was empty. So 2.6 times 10 squared will be 260. 10 times bigger than the previous one. Let's do another one. 2.6 times 10 cubed. Now 10 cubed means you've got 3 tens multiplying. It's 10 times 10, which will be 100, times another 10. And 100 times another 10 will give you 1,000. So 10 cubed is actually 1,000. 2.6 times 1,000, in this case you're just going to move the decimal point 3 places. 1, 2, 3, and you fill out with zeros. So from here that would be 1, 2 gives me a 0, and 3 gives me another 0. So 2.6 times 10 cubed will be 2,600. Again, you can see it's just 10 times bigger than the previous one because we've got one extra 10 here. Here we had one 10 that we were multiplying by, and in fact I could write a little power 1 if I wanted there. Remember, anything to the power 1 is just itself. That power 1 doesn't change what this is, it just means you've got one of them. So we've got one 10 we're multiplying by here, you're multiplying by 10 twice here, there are 3 10s multiplying here. So each time we're increasing the number of 10s that we're multiplying by. But hopefully you can see, each time I multiply by an extra 10, all it's going to do is move the decimal point 1 extra place. 10 to the power 4 means 4 10s, so it's 10 times 10 times 10 times another 10. Now 10 times 10 is 100, times that by 10 is 1,000, times that by 10, you get 10,000. So 10 to the power 4 is 10,000. So we're going to be moving the decimal point here 4 times. Timesing by 1 10, you move the decimal point once. Timesing by 2 10s, you move the decimal point twice. 3, you move it 3 times. 4, you move the decimal point 4 times. So in this case, I'm going to get 26,000. The decimal point was here. We're going to move it 1, 2, 3, 4 times. And we can carry on this pattern as far as we like. The point though is that the power of the 10 simply tells you how many times to move the decimal point. And this little shorthand here, because you can imagine the numbers when they get very big at this end, this doesn't really change very much. Let me just give you one more example if we miss out a few. If I do 2.6 times 10 to the power 9, this isn't any bigger than any of these things. But the number it represents on the other side can get really big. This means we've got to move the decimal point 9 places. So that'll be 1 over the 6, 2, 3, 4, 5, 6, 7, 8, 9. And you can see when you're dealing with big numbers, this way of writing the number is actually much shorter. And we always like to save time and effort whenever we can in maths. So anything that allows us to write something shorter in less space, in less time, we prefer. So as I say, this is used a lot when you're dealing with very big numbers or very small numbers, which we'll come on to in a bit. This shorthand is called standard form, and there are a couple of important things you need to be aware of in standard form. First of all, the number here, which links to the sort of first bit of the big number, always has to be between 1 and 10. So that always comes at the first, and it's always between 1 and 10. It's allowed to be equal to 1, it's not allowed to be equal to 10. So from 1 to 10, not including 10. You then always multiply by 10 to some power. And that's the other key thing you need to work out. So standard form is some number between 1 and 10 times 10 to some power. And the power just tells you how many times you have to move the decimal point. That's how the shorthand works. And it's because of this property that every time you multiply by another 10, it just moves the decimal point another place. One thing I should point out here that a lot of people get wrong with standard form is that the power doesn't tell you how many zeros there are. Sometimes the power is the same as the number of zeros, most of the time it's not, and you shouldn't fall into that trap. You can't just add 4 zeros onto the end of this. The power is how many times you move the decimal point. And this number can be very different from the number of zeros sometimes, so don't think it's got anything to do with the number of zeros. Let me do a couple of examples then of what you can do with this. But that's the pattern. Hopefully if you can spot the pattern, it should make sense. You'll see why we do it that way. So if we try having a really big number with a bunch of zeros, that'll do. Imagine we wanted to write this in standard form. So the first thing is we need a number between 1 and 10. And you've always got that from the front bit on the number. You just have to work out where to put your decimal point so that you end up with a number that's between 1 and 10. If I put it here, I'd have 840 point something, that's too big. Here, 84.00, that's too big. Here, 8.4, that's between 1 and 10, so that's what you use. In general, you always stick the decimal point after the first digit. That always gets your number between 1 and 10. But it's very important, this must be between 1 and 10 or it's not standard form. We then have to multiply this by 10. Don't forget that bit, a lot of people miss that out. And then you need to work out what the power is. The power is simply how many times you've moved the decimal point. So we're going to put the decimal point between the 8 and the 4 here. The decimal point in this number at the moment is at the end. Yeah, this is a really big number. Should we work it out? It's 840 million if you group every 3 zeros. So it's 840 million 0.0 effectively. There is a kind of decimal point at the end there that we don't bother writing. So from the end you just count until you get between the 8 and the 4. So 1, 2, 3, 4, 5, 6, 7, 8 times. So the power of the 10 here is 8. So in standard form, 840 million is 8.4 times 10 to the 8. And that's how you do it. Let's try one more example like this. I'll try something with a few more digits in it. As in a few more digits that aren't 0. Just to see what we do with that. In fact, let me write this underneath so we've got enough space. So if we follow the same way we did before, you need a number between 1 and 10. You always want to put your decimal point after the first digit. 7.6923, etc. That's between 1 and 10 because it's 7 point something. So we could write 7.692318 times 10. It's always times 10. And then work out what the power is. The decimal point is currently at the end. We want to put it between the 7 and the 6. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So the power here would be 11. Now you might be thinking to yourself, well, for a shorthand, this isn't really much shorter than the number we started with. The reason for that is because all these digits here, we just kind of wrote them all out again. And you don't need to do that. What you can do, because this is a decimal number at the end of the day, is you can just round it. And usually with standard form you would do that. The point is to make it shorter than what you started with, so it ends up being just as long, then there's not really much point doing it. So you round decimal places just like you normally do, and it's up to you really. You can round to 1 decimal place, 2 decimal places, it's your choice. Generally, however many usually significant figures they use in the question. That's how many significant figures you use when you round. So let's say we're going to round to 2 decimal places here. That would be 1, 2, 3 significant figures. So your line goes there, you look at the next one, it's less than 5, which means that stays the same. And then you can throw away everything after the line. The times 10 to the power 11 you still need though, otherwise it won't be standard form anymore. But essentially we can get rid of all that and just move the times 10 to the 11 over here. Now you can see this is definitely quite a bit shorter than what we started with, so that would be the standard form version here. One little thing to point out is that effectively 769 we've rounded here. And we've rounded to 3 significant figures. Remember, with big numbers, that's the first significant figure, that's the second one, that's the third one, and that's where we've chosen to round. And it works exactly the same when you just treat the decimal number. So you can round beforehand and then replace all those with zeros and turn it into standard form, or you can turn it into standard form and then round it. Both ways will give you exactly the same answer. Alright, so that's big numbers. Let me show you how really small numbers work. So again, I'll start with a pattern, see if you can spot the pattern. We'll have 3.5 this time. And for small numbers, we're going to be using a negative power. Now, can you remember the rule for negative powers? Let's just remind you quickly. So, if something has a negative power, the way I remember it is you think 1 over the positive. It's always 1 over, and the thing on the bottom is going to be exactly the same as what you started with, except the power becomes positive. So it's 1 over 10 to the power 1. Well, 1 over 10 to the power 1 is just 1 over 10 actually, because the power 1 doesn't really do anything here. So 10 to the power minus 1 is actually a tenth. So 3.5 times 10 to the minus 1 is 3.5 times a tenth. Now if you're timesing by a tenth, that's the same as dividing by 10. So what happens here is the decimal point just moves 1 in the other direction. You're making the number smaller because you're timesing it by a tenth, so the decimal point goes 1 place to the left. So in this case, you get 0.35. Let's try the next one. 3.5 times 10 to the minus 2. Again, let's just look at that 10 to the minus 2 for a second. So you think 1 over the positive, so it's 1 over exactly the same thing, except the power becomes positive. Now 10 squared, as we saw with the big numbers, that's just going to be 100. So 10 to the minus 2 here is actually 1/100th, it's 1 over 100. So you're timesing by 100th. That means actually you're dividing this number by 100. So just like when you were timesing by a tenth, the decimal point went 1 place to the left. From between the 3 and 5 it came before the 3. Now timesing by 10 to the minus 2, timesing by 100th, you move it 2 places to the left. If you're dividing by 100, it goes 2 places to the left. So that's going to be 0.035. Yeah, decimal point was between the 3 and the 5, it's gone 1, 2 places to the left. Next one, 3.5 times 10 to the minus 3. Well, we can just change this into a minus 3, which makes that into a positive 3. So 10 to the minus 3 is 1 over 10 cubed. Now 10 cubed, remember, is 10 times 10 times 10. 10 times 10 is 100, times by another 10 is 1,000. So this is 1,000th. 10 to the minus 3 is 1,000th. So you're timesing by 1,000th, which means you're dividing by 1,000. So you're moving the decimal point 3 times now. Again, notice the power here is minus 3, so you move the decimal point 3 times. So it's going to be 0.0035. The decimal point was here, between the 3 and the 5. We've gone 1, 2, 3 places to the left. And again, just like with the big numbers, when we had positive powers here, each time we were multiplying by an extra 10, and that moved the decimal point 1 extra place. This time though, because these end up being on the bottom, negative powers always become 1 over something, so they're always going to be dividing. So you're dividing by an extra 10 each time. So if it's 3.5 times 10 to the minus 4, that means you're going to be dividing by 1 extra 10 compared with this one. So you're going to move the decimal point 1 extra place to the left. So the power, just like with the big numbers, tells you how many times to move the decimal point. It's no different with small numbers. It's just that instead of moving the decimal point to the right, making the number bigger, with negative powers, you're moving the decimal point to the left. So 10 to the minus 4, you have to move the decimal point 4 places. From here, 1, 2, 3, 4 places to there. So that's how it works, and it's quite a neat system really. I always thought when I first came across this, it's very handy having these negative powers, because it does the exact opposite of the positive powers, but all you really need to worry about is the number. The number, whether it's positive or negative, tells you how many times to move the decimal point. And the only extra thing to remember is, if it's a negative power, it's going to be a small number. So you move the other way. Let's try some examples. So we'll have a really small number, 0.00000, lots of noughts, and I'll stick a bunch of numbers on the end here to show you how you can round with these as well. So we need, for it to be standard form, we need a number at the front that's between 1 and 10. Now we obviously don't want to be putting our decimal point anywhere up there, because that's just full of zeros. This is where you're going to get your number, and if you put it between the 6 and the 7, after the first non-zero digit, it's a bit like significant figures in that sense. You find the first digit that's not a 0, and the decimal point will go immediately after it. So 6.7, etc. will be between 1 and 10, so that's what you need. So in this case, 6.7592 will be the number that's between 1 and 10. And then standard form always has that times 10 in it. You must never forget that bit, and then work out what the power is. Now because it's a small number, any number that starts 0 point something has to have a negative power. So you can put the minus in straight away, but then you're simply counting how many times you move the decimal point again. This case we're going to the left rather than to the right like we were before, but it's exactly the same in that you just count how many times it's moved. So we're putting the decimal point between the 6 and the 7, so to get it all the way over to here, 1, 2, 3, 4, 5, 6. It's moved 6 places, so the power becomes minus 6. Again, we could have rounded this, because you can see it's not really much shorter than what you started with. So I'm going to round to 2 significant figures this time. That would be the same as rounding there. But it works exactly the same here. 1 significant figure, 2 significant figures. So my line goes there, I look at the next one, it's 5 or more, which makes the 7 go up to an 8. So if I round this to 2 significant figures and write it in standard form, everything after the line gets thrown away, the 7 goes up to an 8, and then if I move this over there, it becomes times 10 to the minus 6, because the decimal point moved 6 places. So for small numbers, it's exactly the same. Work out where your decimal point goes, round it if you want to, but just remember, any number that starts 0 point something, the power must be negative. The power still tells you how many times to move the decimal point, it's just that it's negative instead of positive. So that's how standard form works, and as I say, it's just a useful shorthand. You'll see people use it a lot in different science contexts. Let me quickly show you how to work the other way. Sometimes you get numbers in standard form and you want to convert them back to normal numbers if you like. So if we try 2.8 times 10 to the 5, that's a standard form number. The first thing to notice is the power is positive. It's 5, it's not minus 5, so it's going to be a big number. So 2 and the 8 are the numbers we're going to have here, and all you have to do is move that decimal point 5 places. We want a big number, so we're going to be moving it 5 places to the right. So between the 2 and 8, that would be 1 to there, 2, need a 0, 3, 4, 5. So the decimal point is at the end. It's moved 1, 2, 3, 4, 5 places because it was between the 2 and the 8. So as a normal number, 2.8 times 10 to the 5 would be 280,000. Let's try a small one. We'll have 3.97 times 10 to the minus 6. So again, whatever your numbers are here, those are the first, well actually for a small number it's not going to be the first bit, they're the first non-zero digits. Let me write them out here. I'll leave some space for some zeros here. So we need to move the decimal point 6 places. But because it's a -6, it's a small number, it's going to start 0 point something, and we've got to move it 6 places to end up here. It started between the 3 and the 9, it started here, we've got to move it 6 places. So over the 3 will be 1 to there, 2, 3, 4, 5, 6. Yeah, so from here it's going to go 1, 2, 3, 4, 5, 6 places to get there, because the power is 6. So 3.97 times 10 to the -6 as a normal number will be 0.0000397. Again, you could round it if you want to, that's completely up to you. So hopefully that's given you a good overview of standard form, how to convert into standard form, and how to convert back to normal numbers if you need to. My name is Jonathan Hicks, and you're watching Teach Me Maths.